You're listening to the N2K Space Network.
Most environments trust far more than they should, and attackers know it. ThreatLocker solves that by enforcing default deny at the point of execution. With ThreatLocker Allow listing, you stop unknown executables cold. With ring fencing, you control how trusted applications behave. And with ThreatLocker DAC, Defense Against Configurations, you get real assurance that your environment is free of misconfigurations and clear visibility into whether you meet compliance standards. ThreatLocker is the simplest way to enforce zero-trust principles without the operational pain. It's powerful protection that gives CISOs real visibility, real control, and real peace of mind. ThreatLocker makes zero-trust attainable, even for small security teams. See why thousands of organizations choose ThreatLocker to minimize alert fatigue, stop ransomware at the source, and regain control over their environments. Schedule your demo at threatlocker.com/N2K today.
As disruptions to GPS services increase globally, humanity is pushing to find alternative methods to help with positioning, navigation, and timing. Could radio signals from low Earth orbit satellites become reliable navigation alternatives? Well, our guest certainly believes so. This is T-Minus Deep Space. I'm Maria Varmazes. Zach Cassis, professor in the Department of Electrical and Computer Engineering at The Ohio State University, recently released a white paper on navigating the Arctic Circle with Starlink and OneWeb LEO satellites. And he spoke with me about his research findings.
I'm Zach Cassis. I'm a professor in the Electrical and Computer Engineering Department at Ohio State University, or The Ohio State University, so I don't get in trouble. I'm also a TRC Endowed Chair of Intelligent Transportation Systems, and I'm a director of a U.S. Department of Transportation Center, which we call CARMEN. So for Ohioans, that means something, but for those who speak Latin, it means something else. But for us, it stands for the Center for Automated Vehicle Research with Multimodal Assured Navigation. So I focus on resiliency and accuracy of navigation systems in a nutshell.
Excellent. Well, thank you so much for joining me today. And the reason we reached out to you is, as you all know, you've been working on some very fascinating research that you co-authored a paper on recently and presented at the IEEE Military Communications Conference in LA. And this paper won the best paper, the IEEE Frederick W. Ellersick Award. I'm trying to make sure I say the names all correctly, for the best paper in the unclassified technical program. So congratulations. That is not a small accomplishment. And I'm here to basically ask you about the paper that you presented. And again, I know that the answer will always be, please, everybody read the paper, and we will make sure we have links and everything. But if you could give me a sense of the work that you've been working on, because it's fascinating.
Yeah, well, thank you. So it did caught me by a surprise. This is the first time I ever attended this conference myself. So it's not my, I would say, home scientific community. So I was happy that the audience and the attendees and the awards committee appreciated the work. But in a nutshell, what this work is about. So this is a project that we started around 2017, which is, I saw LEO is going to be booming in a good way. And will change life as we know it on Earth. So with the birth of, they're called mega constellations. So a lot of the purpose of these mega constellations, of course, I call Starlink the daddy of all mega constellations. They surpass 10,000 satellites in LEO. The purpose of these mega constellations is broadband connectivity anywhere on Earth, right? But for myself, which I'm, as I said, interested in navigation systems, I saw an opportunity to, let's call it GPS 2.0, right? So GPS is a wonderful system. It had served us beautifully over the years since really the first launch in 1978. So people may not realize how old of a system it is, and it over-delivered what the original designers intended it to do. But the limitations are known. And in recent years, it's been extremely vulnerable. And we got so used to it in our daily lives. And more importantly and more dangerously in safety critical systems like aviation, like military operations, and so on. So I thought the answer is going to be, I'm a big fan of the X-Files. So they say, the truth is out there. I said, the truth will be out there. It will be in LEO. There are these systems that maybe we can exploit for navigation. So we started this work in 2017. We started on satellite constellations before Starlink, so namely the ORBCOMM constellation and the Iridium constellation. They don't have as many satellites, obviously, as Starlink, but that was a good starting point, and we learned a lot so that when we went after Starlink in 2021, we were the first to demonstrate in the world that, hey, you can actually pinpoint your location to within about 10 meters or so with Starlink satellites alone. And that was the beginning of the journey, which led us to this paper. So over the years, we've taken this concept to ground vehicles. We've demonstrated you can navigate ground vehicles to meter level accuracy with Starlink. 2 summers ago, we demonstrated that on a high altitude balloon that flew in New Mexico, reaching nearly 80,000 feet above ground level with Starlink signals alone. And then we started thinking, well, where else could we take this? We've also demonstrated it on UAVs, on unmanned aerial vehicles. So that's a little, I would say, a little boring by now. So we thought, where else could we take it? And the question that I kept getting asked is, what if you are in the middle of nowhere?
Yeah.
Right. So what if you are a plane flying over the ocean? What if you are sailing across the ocean and you lose GPS for one reason or another? So we thought, okay, well, let's take it to the ocean and let's take it somewhere very cold that was in the news and I would say 9 or so months ago, 10 months ago, and we took it to the Arctic. So GPS is not, I would say, you don't have as much coverage from GPS satellites up in the polar region.
Right. Yep.
And it's very, I would say, becoming a very contentious area. And it's important for U.S.'s national security. So really, that was the biggest driver for my interest in the Arctic. So we took it to the Arctic. We wanted to see, are the satellites really transmitting there? And are their signals useful for exploitation for navigating a vessel? And to our surprise, they were not only useful, they were actually more beautiful. And this is a technical term, believe it or not. They're more beautiful than many places where we tested this. We've tested Starlink and looked at Starlink across the U.S. from California to New Mexico to Ohio to Pennsylvania, so to Missouri. So we've seen enough of those signals, but what we saw in the Arctic was something else. So this paper is the beginning of several studies. We have another bigger study that is in the works. But what we showed in this paper is, yes, you can navigate a vessel with Starlink signals alone, or you can also marry them with OneWeb signal. So that's another mega constellation, I would say, number 2 behind Starlink in terms of number of satellites in orbit. And we navigated the vessel for about 8 or so kilometers with an error on the order of tens of meters.
Wow. Okay, so you said beautiful signal, which is I don't think I've ever heard that phrase before, but I'm adding that to my lexicon because that's wonderful. So it makes me wonder about the nature of these signals. So I was reading in the press release that these are not purposely put out by Starlink. This is not Starlink doing. This is passive data. I mean, is this metadata? What exactly are these signals? Just so I can get a sense of what we're picking up on.
Yeah, so basically Starlink transmits a comm signal. Actually, it's a communication signal very similar to how your cell phone operates. And it's something called an OFDM frame, right? So it's similar to 5G and even 4G protocol. Those signals, they are intentionally designed and perfected and optimized for communications. Now, if you want to use them for navigation, it's not straightforward, and that's what makes it a research topic, right? If they were meant for navigation, then it's more of a design or an engineering concern. But what really got us curious about these signals is, first of all, you don't know what they are transmitting. They didn't disclose it. Like the fact that they are OFDM, that's something we discovered and published on, among others, and the literature. How do you use what they are transmitting to be able to navigate? Like, how do you design a receiver that can learn those signals and learn as much as possible from those signals and then allow you ultimately to navigate as if they are GPS satellites? Because that's what we are turning those satellites. And as you said, it's passive. We eavesdrop on the satellite. Starlink doesn't know that we are sniffing its signal and using it to navigate. That's one half or one part of the challenge, is what do they transmit and how do you use it to navigate? The other half of the challenge is, where the heck are these satellites, right? You don't know precisely where they are in space. So GPS tells you precisely to within a meter or so where the satellite is in space. It is intended for you to navigate with it. So it gives you all the help you need. It tells you what the signals are, where the satellite is in space, and it also tells you a lot of the timing error and so forth. It's all taken care of to us by the Space Force, right, and the Air Force. Starlink, it's proprietary. It doesn't tell you any of this. You can get an estimate of where the satellite is in space. It's a coarse estimate. Go online. There are publicly available data files. They are not updated all the time. They promise to update them regularly. Sometimes they miss uploading a file and so on. And they are not super accurate, right? And that's something that's the biggest challenge. In fact, when we started working on this, we were using files with an accuracy of several kilometers.
Oh.
Right? So you barely know where but in space world, this is good enough.
Yeah.
Right? It's a vast, it's a desert, right? It's a vacuum. Whereas if you know something to within few kilometers, you cannot expect to know where you are to within few meters, right? So we also solved what you call the ephemeris problems, where the satellites are in space at any point in time. So when you marry both together without help of Starlink or talking to them or working with them, we were able to more or less reverse engineer Starlink for position navigation and time.
We'll be right back.
The world moves fast. Your workday, even faster. Pitching products, drafting reports, analyzing data. Microsoft 365 Copilot is your AI assistant for work. Built into Word, Excel, PowerPoint, and other Microsoft 365 apps you use. Helping you quickly write, analyze, create, and summarize. So you can cut through clutter and clear a path to your best work. Learn more at Microsoft.com/N365 Copilot.
AI is incredible. It can teach you how to fry an egg and even write a poem, pirate style. Yarr! But it knows nothing about your work. Slackbot is different. It doesn't just know the facts. It knows your schedule. It can turn a brainstorm into a brief. And it doesn't need to be taught. Because Slackbot isn't just another AI. It's AI that knows your work as well as you do. Visit slack.com/meet Slackbot to learn more.
The implications of this, and I know the work is still ongoing, but it is a very known problem about how GPS jamming and spoofing is huge, very dangerous. You mentioned at the top of our discussion. And the solutions to this, I know in the market there are a lot of different directions of how people are trying to solve this. But the larger solution is usually we need to put up more resilient GPS satellite constellations. But in a way, this is essentially saying there is a completely different path. I'm wondering, in your estimation, is this a matter of years, decades? I mean, what do you think this would be possible for using this for resilience?
So that's a good question, and I get asked this often, right? And this is why I like to think of the future of navigation, or the different schools of thought of navigation, especially if you want to look at LEO, like putting more GPS satellites in MEO, in medium Earth orbit. That's not going to solve the problem. You're solving the problem that got us into the issues we have with the same thinking that got us into that problem to begin with. So there is something called physics, right? You cannot
I've heard of it.
simply you cannot simply just put a satellite there that transmits a much more powerful signal, in an economical way or even in a physically engineered way. So that's why people got excited in LEO. And I should say, you see, I don't know how young our listeners are, but people often forget that the greatest thinking had been done in the past, and we reinvent the wheel, right? So Leo for navigation is not a new concept. It's actually started with the satellite constellation called Transit. The first satellite constellation for navigation is called Transit. It's not GPS. And it was in Leo. So people knew that Leo is very attractive for navigation. The problem, it's much cheaper, much closer, the signal is more powerful, and so on and so forth. The problem is you will need way more satellites in Leo than in MEO to be able to instantaneously know where you are anywhere on Earth. So back then, people had to wait for nearly an hour to get a position fix. And I don't think in today's world, you want to wait an hour to know where the closest coffee shop is.
Yeah, nobody's that patient.
Right?
No.
Yeah. So it is not a new concept.
Yeah.
This is why we went to MEO, GPS was born, then GNSS, Global Navigation Satellite Systems, Galileo, GLONASS, Baidu, and so forth. So now we are going back to LEO. Okay, good. What do we do there? And there are three schools of thought. The first school of thought, it says, let's build a dedicated constellation in LEO for PNT, for positioning, navigation, and timing. Kind of like GPS, but we're going to put it in LEO. And there are companies that are doing this, right? Commercial companies. And there are even nations that are thinking about this. Okay, that's fine. The other school of thought, it's dual purpose, whatever we have in LEO for navigation. So Starlink is transmitting a Justin Bieber YouTube video for you. It's also transmitting a PNT signal for you, a navigation signal, right? So they're dual purposing the constellation. I think that's a step in the right direction. And then there is the third school of thought, which is fully opportunistic. And that's what we are doing. Fully opportunistic means you don't really have to do anything. And it's if you think, it's like a superset. If you think of a Venn diagram, this is the superset of both approaches. Because whether you have a dedicated constellation, whether you have a dual-purposed constellation, I can exploit both.
Mm-hmm.
So I realize people may not warm up to it immediately, or warm up to the idea, but it has been getting a lot of traction. And I'll tell you why I'm passionate about this approach.
Please, yeah.
So one, it is very sustainable. Very sustainable for space, right? The first approach isn't sustainable for space. If everyone who can afford, and now unfortunately or fortunately, you can launch satellites into LEO cheaply and replace them every few years. Actually, Starlink launches them as if you're going to Costco, right? They just launch them in these big batches. So what are we doing to space, right? So it's going to be a problem. So it is sustainable from a space environment point of view. It is, and if you're not a space environmentalist, I understand, it is sustainable for spectrum. Why should we license more? Spectrum is probably the most expensive and non-perishable resource out there. Why should we license this spectrum if I can reuse the spectrum that is there? And that's what we've shown. In fact, the idea that we worked on in my lab for many, many years, and I would say perfected up until now, is called cognitive sensing and opportunistic navigation. So what does it mean? I can give you a radio or a receiver that can listen to virtually any signal coming from space, from LEO, and learn what they're transmitting and use it to navigate. So we had successfully applied this technique, regardless what they are transmitting. And every constellation transmits its own proprietary signal with its own proprietary modulation, multiple access scheme. So we've applied it to old constellations, Orbcom, Iridium, and even NOAA. NOAA is the space weather constellation.
Yep. Mm-hmm.
We applied it to Starlink. We applied it to OneWeb. And it worked. And very recently, my student applied it to a constellation that is intended for LEO PNT, which is Zona. Zona transmits a proprietary navigation signal. Said, you know what, we're going to crack their signal as well and use it without their knowledge to navigate. So it is a green approach, if you will, right?
Yeah.
The spectrum is licensed for other purposes. Why can't we use it? Why can't we share it? I came up with this analogy. I don't know if it makes sense for our audience, but think of Uber, right? If you do not have enough taxis in a city, the solution is not to throw in more taxis in a city and overwhelm the city with congestion. Why don't we repurpose cars that are driving around for transporting humans and goods, right? So that's the opportunistic approach, if you will. And let's see, there are 3 competing schools of thought, and only time will tell which one will get mass adoption.
I think it's going to be fascinating to see. I cannot help but wonder, have you heard from any of the satellite operators about your work? Because I mean, the word that you've been using is exploiting, and it's there. It's not like you're stealing something. So, but I understand the sense of how you're using that word. So I'm just curious if you've heard from the satellite operators at all, or any of them.
We have. We often get contacted by all kinds of people, and including some of the big satellite operators. But technically, the signal is out there.
Yeah, that's right.
The moment you transmit it, and we are only listening to what we call synchronization sequences. We are not listening to data traffic, nor we have that capability or interest. We're listening to, synchronization sequences that are out there that allow us to navigate. So yeah, we have been contacted by some of these operators, and they're aware of what we are doing. Actually, some of them even learn about their system from what we are doing.
I was going to say that's really neat. I mean, it's a really interesting concept, and I mean, I'm really looking forward to hearing the subsequent research that you all are working on as well, because if the signal is there and it's a matter of just being able to pick it up, that honestly sounds like an opportunity for a lot of these providers as well. So. This is very fascinating. So I really appreciate you taking the time to explain it to me. Just genuinely thank you. And congratulations again on your paper winning the award, the IEEE award. That is really wonderful as well. So thank you again, and all the best on your research. I look forward to hearing more.
Thank you very much, Maria, and all the best to you and this wonderful podcast, and to your audience, learning a lot about space, which is an era we are living a renaissance of. So thank you very much for the opportunity.
That's T-Minus Deep Space, brought to you by N2K Cyberwire. We'd love to know what you think of this podcast. Your feedback ensures we deliver the insights that keep you a step ahead in the rapidly changing space industry. If you like our show, please share a rating and review in your podcast app. Or you can send an email to space@n2k.com. We're proud that N2K Cyberwire is part of the daily routine of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K helps space and cybersecurity professionals grow, learn, and stay informed. As a nexus for discovery and connection, we bring you the people, technology, and ideas shaping the future of secure innovation. Learn how at n2k.com. N2K's senior producer is Alice Carruth. Our producer is Liz Stokes. We are mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Peter Kilpie is our publisher, and I am T-Minus host, Maria Varmazes. Thank you for listening. See you next time.
If you only attend one cybersecurity conference this year, make it RSAC 2026. It's happening March 23rd through the 26th in San Francisco, bringing together the global security community for 4 days of expert insights, hands-on learning, and real innovation. I'll say this plainly, I never miss this conference. The ideas and conversations stay with me all year. Join thousands of practitioners and leaders tackling today's toughest challenges and shaping what comes next. Register today at rsaconference.com/cyberwire26. I'll see you in San Francisco.
This episode is brought to you by Dead Man's Wire, the new film from Roque Entertainment. Dead Man's Wire is the incredible true story of the 1977 kidnapping that turned an aspiring entrepreneur into an outlaw folk hero. Directed by legendary filmmaker Gus Van Sant, Dead Man's Wire stars Bill Skarsgård, Dacre Montgomery, Cary Elwes, and Myha'la, with Coleman Domingo and Al Pacino. Now playing in select theaters everywhere January 16th.